Okay, welcome to Psych 200, Research Methods, Introduction to Research Methods. Today we're talking about single subject research designs. Okay, let's get started. Okay, so what are single subject research designs? Well, the name kind of says it all. They're studies where you only use a single subject. And that's a type of case study, by the way. Okay, so but here we're spending a whole lecture on this, and we're calling them single subject designs. Okay, we're going to talk about the single subject designs where there is some kind of treatment. Okay, so single subject design, also called single case designs, because technically they are case studies. Okay, are research designs that use the results from a single participant or subject. Okay, a participant is someone who basically volunteers, gives permission to be in the study. A subject does not, by the way. A subject could be an animal, okay? So it's a study that uses a single participant or a subject to establish the existence of a cause and effect relationship. So it's a basically intensive study of it's a study basically involves either one individual, or by specimen, usually we mean one animal, okay? But with a single subject design, you manipulate an independent variable and you control extraneous variables to prevent alternative explanations for the research results. So it uses some features of an experiment, okay? But this isn't really an experiment, it's a single subject design. It's like an experiment on one person, or an experiment on one rat or something like that, one pigeon, something like that, okay? A single subject design. Speaking of pigeons and rats, you might remember from Psych 101, let's see, B.F. Skinner, Thorndike, those were behaviorists that like to study animals, and often they would use one animal and do something like this to basically to make their claims about what causes behavior. So that's a single subject design. It's just a study where you only use one participant, one subject, but you do try to manipulate an independent variable, control other extraneous variables to get at cause and effect, although it's not a true experiment. Okay, we need to know some terminology. We need to know about phases and baselines and phase changes. So a lot of this is going to be terminology. Without the terminology, it's actually very simple. So you need to know what a phase is. A phase is just a series of observations of the same individual under the same conditions. Okay. So a phase is just when you observe several times or over a period of time. That's all that means. Now, a baseline observation is a type of observation when there is no treatment being given. So you're observing when there is no treatment. Okay, baseline, like at baseline, how do you normally behave? What is your normal breathing like? What is your normal mood, or whatever it is? That's baseline. Okay, so baseline observations are observations that are made when there's no treatment. If you have a baseline phase, remember a phase is a series of observations. A baseline phase is a series of baseline observations. A baseline phase is basically when you're observing over a period of time, several times, and no treatment has been given yet. Okay, and that's identified by the letter A. Okay, and you'll see what we mean in a moment with these letters. We also have treatment observations. Treatment observations are basically observations that are done when there's some treatment being given. Maybe it's a drug, maybe it's exercise, but there's some treatment. Okay, this would be your independent variable if we were talking about an experiment. Okay, so those are your treatment observations. Okay, observations made while treatment is being administered. Okay, now the treatment phase would be a series of treatment observations. So it would be when treatment is being given over a period of time or several times. Okay, and that's identified by the letter B. Okay, so why letter B? I don't know. Okay, but probably they're just following the the alphabet here. A is for baseline, B is for treatment. Okay, and designating these different phrases by different letters, they use A, B, right? This allows researchers to describe the phases in a study by using a sequence of letters. So it's kind of a shorthand, right? Using A and B, for instance. A, B basically means that first they observe when there's no treatment, and then they observe during treatment, and they know what happens. Okay, let's keep going. There's other terminology. You need to know what is meant by a consistent level and a consistent trend. With a consistent level, what we mean there is that when you take measurements, that basically all the measurements are nearly the same magnitude. So that means that there is no increase or decrease, it's consistent, okay? Whether you're graphing, let's say, or you're plotting the points, or, you know, or you're observing, let's say, heart rate, temperature, or whatever it is, if it doesn't vary very much, then they're all nearly the same, all nearly the same magnitude. And when you graph it, the points are going to be in a straight line, in a horizontal line, horizontal like the horizon, okay? Not necessarily straight, okay, straight line, but horizontal, okay? A vertical line is also straight, but a straight horizontal line, okay? A consistent trend means that there's a consistent increase, okay? There's a trend, okay? It's not horizontal, but there is an increase, for instance. The difference from one measurement to the other, to the next, right, is consistently in the same direction and nearly the same magnitude. The data points cluster around a sloping line. That's a consistent trend. I should correct that. It doesn't have to be a consistent increase. It could also be a decrease, by the way. It just means there's a slope to the line and things are either going up or down. So consistent increase or decrease. All right, let's keep going. Stability. Stability means that degree to which the observations show a pattern of consistent level or consistent trend. Stability means basically that there isn't really much of a change in pattern. You see the same pattern, okay? Stable data may show minor variations from a perfectly consistent pattern. So you can have, you know, some changes here and there, but they're not big changes. Variation should be relatively small and the linear pattern should be clear. Now I know this sounds like just like a bunch of terminology. Some of you maybe don't even know what the heck I'm talking about, or this just seems boring, right? I'll show you some graphs in a moment that illustrate what this is really referring to. It's pretty easy to understand, but when you're hearing it for the first time and you're just hearing this terminology, it doesn't mean much. But we'll look at some graphs and then talk about some applications. So here we have some graphs here to make this clear. We have there the one on the upper left, right? There we have a stable level, okay? So you can see that it's stable, right? There are variations in the data up and down a little bit, but it's relatively consistent, okay? So that's a stable level. Now with a stable trend, remember with a trend, there can be an increase or a decrease, even though the PowerPoint only said increase, okay? But stable trend means that basically that it has a slope, okay? The line has a slope. It's not horizontal, okay? It has a slope, and if it's stable, that means that the line, it shows some variations. You can see that it's not a perfectly straight line with a slope, okay? It's kind of a crooked line. It goes up and down a little bit, but not much. It's still stable. It's pretty consistent, okay? That's a stable trend. If it's a trend, it means it's either going up or down. Okay, and if it's stable, that means it's not varying that much. So we have stable level, stable trend, and then we have here we have data that is unstable. Okay, the one at the bottom there in the middle, okay, C, that one is shows instability. You can see the data, you know, the points go, you know, up, and then they come down a lot, and then it goes up a lot and down. That's what we mean by unstable. There's a lot of variation. Okay, not a little bit of variation, a lot. It's not consistent, okay? It's not level. It doesn't appear to be a trend. It's kind of all over the place. That's what we mean by unstable. And you could think of this in different ways, like A there, the stable level. That might be maybe your temperature. You know, that they're measuring your temperature over a series of, let's say, of minutes or even hours, and it's staying relatively consistent. It may go up a little bit, down a little bit, you know, but it's relatively consistent. And stable trend there, a stable increase. You know, that might be your heart rate, let's say, when you been told, let's say, that you have to, give a speech in front of the class in like 5 minutes, right? And then they measure your your heart rate there, and it starts to go up consistently because you're anxious, you're nervous. Maybe in 10 minutes, right? So they check during those different minutes, right? Minute 1, minute 2, and your heart rate is going up because as the time approaches, you're getting more and more nervous. Just to give you an example, okay? And these are examples I'm making up. It may not exactly work that way, but just to help you understand. Now, there's different kinds of these single subject designs. A very common one is called the AB reversal design. It's called the reversal design because AB, right? And then AB again, okay? First it's A, and then B, right? And then A and B, okay? You reverse it, okay? So an AB design, also called a reversal design, consists of 4 phases. And you should already know what phases these are from just looking at the letters. But first we have a baseline phase. First we observe the participant under normal conditions. Nothing has been done to this participant. Okay, so maybe what's normal heart rate, for instance. We observe that for several minutes. And then we follow that with a treatment. We give some treatment, okay? So maybe we, we produce a loud noise, let's say. That would be B. We see what happens to the heart rate, okay? And then we return to baseline, right? No more noise. And let's see if the heart rate returns to baseline, okay? And then we repeat the noise again. We repeat the treatment, B again, okay? That's simply what it is, okay? First baseline, then treatment, get rid of the treatment, baseline again, and then treatment again, okay? The goal is to demonstrate that the treatment causes changes in the participant's behavior, okay? We see that there's a change from A to B, right? As we go from baseline, and then we initiate the treatment, we see a change. And then we get rid of the treatment and we see it go back to baseline, and then we initiate the treatment again, we see the effect again. Okay, that's the AB reversal design. How do we demonstrate that the AB design causes a change in behavior? Well, we look at the pattern of behavior in each treatment phase, right? We look at the pattern, okay? There's a clear difference. The pattern is clearly different from the pattern in each baseline phase, okay? Clearly different from the pattern in each baseline phase. So we see a clear pattern. We see an increase from A to B, for instance, okay? And then it goes back down, okay, when we take away the treatment. And then we observe during baseline, and then we give the treatment again. So we see a very clear pattern, okay? And that's how we know that behavior is changing. The changes in behavior from baseline to treatment and from treatment to baseline are the same for each phase change, for each of the phase change points in the experiment. So we see the same pattern, okay? We see the same pattern twice. We see a pattern as we go from A to B, okay? And then we see the same pattern again from A to B when we repeat it. So we demonstrate the effect twice, thereby being able to show that it's not just a one-time thing. So here's some example for you guys, okay? So we look at A there at the top, that graph, right? A measure of behavior, right? We're looking at behavior. So A maybe is, again, let's say it's normal. It makes more sense to think of medical things for these things, but it could be behavior. So let's say A, just to make it more psychological, let's say A is you, let's say just, nail biting or something like that. So you tend to bite your nails a little bit, right? Normally. And then they tell you that, you have an exam coming up. That would be the treatment, let's say. So you start biting your nails a little bit more because you're a little bit more anxious, okay? And they tell you, oh, never mind. Actually, there's no exam after all. You return to baseline. That's A again, right? Normal nail biting. And they say, oh, I was actually wrong about that too. There actually is an exam. So then you get anxious again, you bite your nails a little bit more. Just to give you an example, okay? But we see the pattern from A to B, okay? Twice. We see the increase from baseline, when we initiate the treatment, right? We see the increase, right? From A to B, and we see it again from A to B. We get rid of the increase, by the way, after B, when we get rid of the treatment, we go back to baseline, go back to A. So we see the effect twice. We have B right there, another example. Okay, we could also show a decrease. Okay, let's say A is like, let's say when you fall asleep, right? You go to sleep, A is basically your heart rate begins to drop normally, right? That's baseline. Your heart rate begins to drop because you fall asleep. And as you get deeper and deeper into sleep, your heart rate slows. And then the treatment B would be they basically wake you up. You know, they shake you and say, hey, wake up. So then your heart rate returns to normal. That would be B. Now that would be during waking, okay? And then they let you fall asleep again. That's A, and your heart rate begins to drop. And then B, they wake you up again and your heart rate increases. That would be another example. But the point of the AB design, reversal design, is basically that they show the pattern twice, from baseline to treatment, and then again from treatment, from baseline to treatment. They show it twice. How do you know if you have statistical significance or if what you've demonstrated is practical, if it means anything? Okay. With these research designs, right, with single subject research designs, a statistically significant result means that the observed effect, what you're actually looking at, you're looking at the data on the graph, right? The observed effect, whether large or small, is very unlikely to have occurred by chance. So statistical significance basically means that you look at the graph and you see, hey, look, right? You can clearly see an increase here, right? And you see it here again. Obviously, something's happening, so therefore, it's a real difference. That's the way they determine that. No statistics, no doing any t-tests or any other tests, you know, any ANOVAs or anything like that, right? It's just like, look, right? You can clearly see in the graph here that there's a difference. That's the way they show it, okay? Practical clinical significance means that basically the treatment effect is substantial and large enough to have a practical application. That's what that means. So I'll give you an example. Let's say that a company uses some reward program, okay? So they check the normal level of spending. Let's say you have a credit card for that company, okay? And they have a bunch of customers, okay? And they can check the, okay, you can check with one person. Okay, this is a single subject design. Let's not get confused. I'm getting confused here, but one person, let's say, we have the normal level of spending for this person with their credit card for a certain company, okay? And then the company decides that, so you check their normal level of spending, let's say over weeks or months, and then the company decides that they're going to start a rewards program where they reward participants for spending, right? For using the credit card. They're rewarding you for basically spending more money, okay? For shopping more. So they institute this reward program, and then they see that the amount that you now charge, the amount that you now spend goes up. Because they say something like, okay, for every $5 you spend, we're gonna give you $1 as a reward. It's like a 20% reward or something like that, right? That would be a big reward actually. So what do? You spend more money so you can get more rewards. And as you spend more money, they make more money, okay? So maybe, okay, so 20% is a big difference. But what if the difference was only a few dollars? Maybe you only spend a couple of dollars more with this reward program. Or let's say the company only makes a couple of more dollars for this customer, right? That seems to me maybe that it's not too practical, that it didn't really make much of a difference. But if you spread this out over their thousands of customers, or maybe millions of customers, those $2 times millions can make a huge difference for the company. Just to give you an example, right? It could be a small difference, but multiplied by many, it can be a big difference, okay? But practical clinical significance, it means that there was a change that's basically big enough so that it can be practical. It's something that can be done that would be worthwhile, okay? Let's keep going. Now, there are also multiple baseline designs. So we're gonna make things a little bit more complicated now. And it can get very complicated, by the way. And I don't get into the very complicated stuff, just so you can know enough about this. But yes, this can get complicated, okay? There's multiple baseline designs, okay? The AB design is actually controversial, okay? Because treatments are removed. Let's say you take away medication from someone. So let's say somebody is sick, okay? You observe them during baseline, right? And then you give them the treatment, they get better. And then, you take away the treatment and then they get worse. And then you give them the treatment again, they get better again, right? Notice when you're talking about medication, you're taking away the treatment. Maybe the treatment's working and then you take it away and then people suffer. So it's controversial because of that, okay? So the AB design is limited to evaluation of treatments with a temporary effect. So usually when they do these, they only do this with treatments that basically after a while they wear off. They're not permanent. But if you're talking about something that could really help you over the long term, it would be cruel to take that away from people, even if you're just doing a simple single subject experiment, okay? So it's controversial because of that. Hey, like, hey man, this AIDS drug was working. Why the hell you take it away from me? Now I'm suffering again, or whatever it is. Or now I'm, I have cancer. Like, what the hell, man? You're gonna shorten my life. So it's controversial because of that. Now there's a way around that problem. And of course, the way around that problem is to use multiple baseline designs. And I'm gonna explain what that means. With multiple baseline designs, you can evaluate treatments with long-lasting or permanent effects, okay? It requires only one phase change, like A, B, right? So you observe under treatment, baseline, then you give treatment, right? And then you don't take away the treatment. There's no need to return to baseline. And I'll explain how that works. You're gonna use multiple baselines, okay? And what do we mean by that? So with multiple baselines, what you do is you begin with 2 baseline phases, 2 participants. So rather than 1, you use 2, okay? Or you can use more, okay? But let's say 2, right? 2 simultaneously baseline designs, okay? What you do is, so you begin by observing 2 participants, okay? Both of them are, are just under normal conditions. Nothing has been given to them. They haven't started any treatment, okay? And then what happens is you start treatment. The treatment phase is initiated for 1 baseline. You give one of the participants the treatment, okay? And you continue observing the other one without treatment. And then you initiate the treatment for the second baseline. You give the treatment to the second participant at a later time. So you don't have to take away the treatment. You just start a different treatment for a different participant at a later time. So you're still showing the same effect twice. Now, there's different types of multiple baselines designs, okay? Multiple baselines across subjects is when you use basically more than 1 subject. That's what we just described. So the initial baseline corresponds to the same behavior for 2 separate participants, let's say. So when you use 2 different participants, that's multiple baseline across subjects. And that's the example that we're talking about here with the participants. Now, there's also multiple baselines across behaviors. With multiple baselines across behaviors, rather than using 2 participants, instead you use 1 participant, but you basically study more than 1 behavior. So the initial baseline phases correspond to 2 separate behaviors for the same participant. So you observe, let's say, interrupting, that's 1 behavior, and aggressive behavior in the same design. So first you observe, like, you establish the baseline for both behaviors. So first you observe the participant and you see, okay, what is the normal level of interrupting, let's say for this child, okay? Let's say it's a child, right? What is the normal level of interrupting? And you graph that, okay? And then you also observe the normal level of aggressive behavior. What is the normal level of aggressive behavior for this same child? You graph that. And then you initiate the treatment for the first behavior, for the interrupting, okay? And then continue to observe the second behavior, the aggressive behavior, without any treatment, okay? And after a brief period, after a short amount of time, right, you initiate the treatment for the second behavior. Okay, so you give a treatment for the second behavior. There's 2 different treatments, 2 different behaviors, okay? And there's also multiple baseline across situations. So here, the baselines are going to correspond to not different participants, not different behaviors, but different situations, say like at home and at school. So the initial baseline phases correspond to the same behavior, okay? Let's say disruptive behavior, the same behavior for the same person, but in separate situations, let's say at home and at school. So you're basically going to observe the normal disruptive behavior at home and the normal disruptive behavior at school. Okay, that's baseline. So the child exhibits disruptive behavior at school and at home. Those are the two situations. You established a baseline for both situations. What is the normal level of disruptive behavior at home? What's the normal level at school? Okay, you have two graphs there, okay? Then you initiate treatment for the disruptive behavior at school. You continue to observe the normal disruptive behavior at home without any treatment. And then after a while, you initiate the treatment for disruptive behavior at home. So it's the same thing, it's just that now it's different situations. So it could be different participants getting the same treatment, okay, at different times. It could be different behaviors that are treated at different times, or it could be different situations where treatment is initiated at different, it could be where treatment is initiated in different situations. Now, this will make it more clear over here. It's always more clear to look at the graphs. So here we have a multiple baseline design, hypothetical data, right? It's made up, this isn't real, okay? But just to show you how it would work. So you have at the top there, so the top part of the graph there, you have behavior for participant 1. So look at the upper left right there, it says behavior for participant 1, okay? So we have the normal, let's say, disruptive behavior, let's say, that's baseline. You can see it's, it's pretty high, okay? And then you give them some treatment. It's some drug or something that calms them down, let's say, right? And you can see that the disruptive behavior goes down, okay? And then, so you showed the effect there. And you also have, you also observe the behavior for participant 2, okay? At the same time, okay? So you're observing the disruptive behavior for participant number 2. You started observing the behavior for participant number 1, and at the same time, you started observing the behavior for participant number 2, okay? Except that the behavior for the normal behavior, disruptive behavior for participant number 2, you observe for a longer period of time, okay? For participant number 1, they start treatment, but participant number 2, you just continue observing them, observing their normal behavior without treatment. And then sometime later, they get the treatment and you see the improvement in their behavior. You see the decrease in disruptive behavior. So all we're doing is we're giving the treatment, to different participants, and we're showing the effect again twice. We're showing A, B, right? Baseline treatment for participant 1, and then we're showing the same thing, baseline treatment for participant number 2 at a different time. That's a multiple baseline design. So we don't have to be A, B, right? We don't have to take away the treatment for one participant. If we use two, right, participants, we can continue the treatment for both. We just show the effect twice, but for 2 different participants. I hope that's clear, right? It's actually pretty simple if you think about it. Oh, by the way, just to point it out, that's across subjects. If you're talking about across behaviors, it would be very similar, except that where it says behavior for participant number 1, you would put behavior for, it would be behavior 1, right? And then the one on the bottom says behavior for participant number 2 would be behavior 2. And that's what it would look like, okay? Now we have the same participant, different behaviors. If it was across situations, it would be, where it says behavior participant 1, it would say behavior for school. No, for home, let's have home first, right? Behavior for home, and then behavior, and where it says behavior for participant number 2, it would be behavior for school, right? And you note the disruptive behavior, then you give treatment at home, note the disruptive behavior, give treatment at a later time for school. And that's the same thing, okay? It's a multiple baseline design, now it's across situations. That's how it works. And you can see I only gave you one example here for participants, but I told you about the other ones just so I can cut down a number of slides, limit this to one lecture, because I do know that it's not that interesting. I don't find it that interesting. You guys probably don't either. Some of you may actually have to use this though. If you become clinical psychologists and you decide that you're going to treat people one-on-one, you might do something like this, where you actually check how treatment is working for one participant or one person that you're treating. Or maybe it could be a therapy, okay? There's other types of single subjects designs. There's a whole bunch of different types, by the way, and they can get complicated, but we're not going to get into the really complicated ones, but we'll talk about some other ones, okay? There's also a dismantling or component design analysis, right? A dismantling design where you take away pieces. It's also called a component design analysis. Component analysis design, same thing, right? It consists of a series of phases, right? And then each phase, okay, each next step, we could say, right, adds or subtracts a component of a complex treatment. So this design determines how each component contributes to the overall treatment. So let's say, I'll give you an example, a simple one first, that only consists, let's say, of maybe 2 components, okay? Or let's say 3, because if it's 2, it's too simple, okay? So we have, let's say, we wanna see what works best for, let's say, for losing weight. So we have, let's say, a design where we have the participant, let's say the participant is exercising, following a healthy diet, and also taking medication for weight loss. They're doing those 3 things, let's say, right? That's what they're doing at the beginning. And the next phase, what happens? You take away the medication. Now, how much weight are they losing? Of course, you can observe them over time, right? And then at a later time, you take away the healthy diet. Now they eat normally. Now, how much weight are they losing? And then eventually, let's say you could even take away the exercise, right? No exercise, no healthy diet, no medication. Now, how much weight are they losing? So you can figure out what's, what the effect is at each step, right? That would be a dismantling design. You can also do it the other way, where you add treatments, you add components. You can start with no healthy diet, no exercise, no medication. And then you can add, let's say, medication. Let's see what that does. Okay, and then let's add also now the exercise. Let's see what that does. And now let's add the healthy diet and let's see what that does. And we can remove things, take things away to see what the effect is of each one. You can do that with medication. Like treatment for AIDS, for instance, is a cocktail of medications. There's a whole bunch of different medications. They can do a dismantling design to see which ones which medications actually are having the most effect. They can remove one, add another, right, to see which one is working. But I believe that that example comes up. Here's an example, but not with AIDS, but this is another example. Here's an example of dismantling design. So you have a treatment for autism, let's say, that involves component A and component B. Component A is reinforcement for communication. So you reward the child, let's say, for actually talking, because children that have autism are on the spectrum, sometimes don't want to communicate, often don't want to communicate, okay? And component B is you punish basically biting, or you punish bad behavior, right? To keep it more general, right? But yes, there's also that bad behavior. Those that are on the autism spectrum, they not only don't want to talk, right? But they may also show behavior that's very emotional, okay? Where they throw tantrums, right? They do repetitive things that are annoying, whatever it is. But the point is we have 2 treatments. So we can start first with the total treatment for both components. The child is receiving both treatments, both components, total treatment, okay? Treatment for, they're receiving the reward, right, for communication, and they're receiving punishment whenever they bite. And we know how the child behaves. And then we remove the punishment, but continue, of course, the reward for communication. Let's see how the child behaves now. And then again, let's give them both treatments, right? Let's go back to both components, okay? Show the total again with whatever the effect is with the total treatments. And now we move to the 4th phase. Now let's remove reinforcement. Let's remove the reward for communication, but continue the punishment for biting, let's say. Right? We see what happens, and then we use the total treatment again. So we go back and forth. We add one, we remove one, right? We can do that. There's a combination of things you can do, right? You can add one, then you can add another, you can remove one, remove another. There's different ways you can do this, but it is dismantling. Okay, you start with a total, and then you take one away, you go back to the total, take another one away, or you can keep taking things away to see what's happening. That's called dismantling. You can also do the reverse where you add things, okay? You can add treatment, right? You can start out like, let's say for treating AIDS, you can start out with a certain drug, then you can add another, and then add another, right? And you can see what happens. And that's kind of how they figured, by the way, that these drugs work. Like when they treat the treatment for AIDS, it's not just one drug, it's a whole bunch of different drugs. It's what they call a cocktail, okay? And the drugs seem to work better together than alone. And they figure that out by doing stuff like this. Dismantling design, where it's just they take things away, or or they can actually add components, okay? But either way, we call this a dismantling or component design analysis. Okay. There's also treatments like that for COVID-19, believe it or not. That's what Trump was getting, a whole cocktail of things. And it seemed to work very well. Okay. But it is an experimental drug, that they were working on. I guess it was serious enough, right? The Trump was suffering seriously enough that they gave him this experimental treatment. Okay. So yeah, trust me, right? If they do something like that, it was pretty bad for him. Okay. If they wouldn't have treated him, who knows what would have happened. I know some of you may not believe that, but yeah, when you rush to use some experimental treatment that's not really tested, that means things are serious. Okay. But he got a lot better. General strengths and weaknesses of the single subject design. What are advantages and disadvantages? Okay, so first, advantages. Okay, so one, it allows researchers to establish a cause and effect relationship with one subject. So you can see the effect with one subject. Okay, you can clearly see it. However, it's one subject only. Okay, it allows flexibility. The researcher is free to modify the treatment or change to a new treatment if a subject fails to respond to the treatment. If there is no response, right, you try a drug, the subject doesn't respond, there's no change in behavior, okay, there's no improvement, right, then you can, not use that one and let's try this other one instead, right? When you're dealing with one subject, you can be very flexible. The treatment that we're using for Trump, right, they were giving him that cocktail. If it wouldn't have worked, they would have immediately tried a different one. And if that didn't work, they would have tried a different one. When you're using one subject, you can easily change things around. When you're using a bunch of subjects, you can't do that, because when you're using a bunch of subjects, what you'll find often is that the drug is working for some subjects and not others. And you can't just take it away from all of them. There's other things that come into play, okay? If you take it away from all of them and now you're going to try a different drug, now you have to determine the dose for every single person, what's appropriate. It's more complicated. You can be more flexible when you have one participant. You can easily add and remove things. There's no need to standardize the treatment across groups. You have a single subject. There's no need to figure out the dose for a bunch of different subjects. You only need to do that for one participant. So it's more simple, right? And that's a strength of that. That's an advantage. But there are disadvantages, okay? One disadvantage, and it's a very important one, is that the relationship among variables is only for one subject. So they may talk about cause and effect, right? But it's really one subject, right? That threatens external validity. Can you really generalize from one subject, right? So the drug worked for one person, right? Let's say it worked for Trump. Is it really going to work for everybody else? Notice Trump is old, okay? Probably has health issues. He's obese, right? Is it going to work, let's say, for a healthy younger person who is also gets, let's say, the virus, and that person is not doing very well? You can't really say it's going to work for that person. And that's why when they're developing drugs, they have to use a whole bunch of subjects to determine if they work. First, just a few. Actually, first what they do is they start with animals, okay? And then more animals, And then eventually they move to humans, just a few humans, and then more humans, hundreds of humans. They start with a few humans, then they go a few dozen, then they go to hundreds, and then they go to thousands, and then tens of thousands before they can get approved for the drug. So it's a series of steps, which is why it takes years to develop a vaccine or a drug. But of course, during this time of crisis, right, they are rushing to develop an effective treatment. How are they doing that? They're probably skipping some steps, to tell you the truth, okay? So hopefully everything will be okay and they'll still get an effective drug, or maybe they'll have more than one. There's many companies working on treatments. Another disadvantage of single subject designs is that you need multiple continuous observations. So you need to observe over a period of time, okay? Multiple times. You need to observe under baseline, under treatment, and you need to do it for a period of time. Now, sometimes I told you guys that it could be minutes. Usually it's not minutes. It's usually, we're talking about hours, days, weeks, months, right? If you really, want to know if something is working, like a drug, right? It depends on the drug, right? It depends on, the treatment. It depends on what they're suffering from, the person that you're trying to treat, okay? And another big problem, which is, in my opinion, a very important one, is that the reliance on graphs to demonstrate that the treatment effects are real. Look, right, you can clearly see on the graph that there's something happening here. The treatment effects must be large and immediate to produce a convincing graph. But you're just looking at a graph. And I can tell you this, okay? It's very easy to look at a graph and misread it, to think that there's a real effect there and there isn't. It's very easy for the researchers to basically make that graph look like there's a large effect, when in fact there is not. Okay, it's very easy to fake things if you're just using graphs, is what I'm saying. Okay, those are disadvantages. It's like doing an experiment with one person, okay, with these things, the single subject designs. And experiments are really done with multiple people, and they're really more complicated. And you'll see when we talk about them that they're more complicated. But we'll talk about that after the second exam. Okay, that's it, you guys. That is the last slide. So I'm going to stop recording now.